well, this is a later disclaimer of something I didn't realize. And now that I'm working with my own data, I am realizing, and I hope it doesn't mess you around or confuse you. So I'm just trying to minimize everything in the background so I can put these two screens. So in the tutorial that I showed you, so on the right hand side is the base station database, and on the left hand side is one of the survey databases. And so I didn't read, and I'm sure it was in the tutorial and I just didn't pay attention, but the base station database, you can see the gravity value is 900,000, whereas these readings here are around 600,000. And so I was doing this with my own data and I was getting out the wrong values when I did do this gravity correction. And so I was getting out smaller values, and then when I did the latitude correction, everything blew up and I didn't really understand why. And so coming back and looking, I've now noticed that these two values are different. And if you remember in the video, I said, why the heck do we have different data sets? Like, if the base values are in the survey data, why do you need a separate database for the base? So I suppose this makes sense. And I suppose the alarm bell started ringing when I was making my own base database, and you only need one entry. And I was like, well, which one do I choose? I don't know what the actual gravity value is here. So I suppose it all makes sense now. I hope I'm not doing it wrong, but this is what I'm going to do with my data, is that under gravity and gravity corrections and simulate absolute gravity station, I was confused. You remember I mentioned to you, sorry, let's close this, when we go over here to this correction, that it talks about absolute gravity calculation. And I said to you that I was confused at this point because absolute gravity usually refers to the stations around the world that are accurately measured, and like not every gravity survey has that. So I was confused why Geosoft used the word absolute gravity station. And I suppose that makes sense now, because if you don't tick this, you'll see. So let's go. Where did I have it? I was busy trying to do calculations. Okay, so I was in this database. So I'm not going to be using my master database here. I'm really just calculating it for this single day. And so I just want to show you what I mean. If I go gravity corrections and I take off this last one here, and remember I'm doing the height correction and the drift correction, and I click OK. You can see I've got a drift correction, a height correction. Let's hide these so you don't get confused by those, because that's the latitude. And I'm going to hide that and just move it over here. So we're doing a tide correction, a drift correction, and what we are getting out is this. And it's a value of 6,000. And now the problem is you now go, so, and the reason why it's 6,000 is because here we've taken off this tick of absolute gravity calculation. You'll see if I click on it and I tell it which base station to use, and remember this base station value is in the 900,000s, I click OK, you can see this value jumps up to 900,000s. And it's because it's now doing this absolute calculation relative to this well-known station, which you do need to do, because if you now go and do your drift correction, so let's, I'm sorry, not drift, your latitude correction, and I click that, I click OK, and again, I just want to put everything in the order that it happens so we don't get confused. You can see it's done a latitude correction, and that's looking at the shape of the Earth, and that's big. It's this 900,000 value. And now the final corrected value looks something like this. Okay, and it now jumps down to a small value. So you can imagine if I don't do this absolute gravity correction at this stage and I land up with these 600,000s, I then get a big value for the lat correction. By the time I get to here, I've got unusual values, which I suppose is not the end of the world. So let me show you what it means. So if I don't do this absolute gravity calculation here, I take it off. I click OK. These values jump to 6,000. I now do my latitude correction. You can see now it gets to this minus 9,000. So it's because here we're not doing this absolute correction. And so I think then it's better to actually bring in this absolute correction over here. And so it then means you have to make sure your base station that you're using, you've got a value here that's an absolute value. And so if you haven't done something, you haven't got an absolute gravity station in your area, you can simulate it, which is this one here, which I kind of skimmed over because I didn't think it was important. And so you would come here and put in, so the base station database, I've got line selected all, latitude channel is, sorry, latitude, elevation channel you're going to put in, and your absolute gravity channel, you could choose gravity. So the main thing is now, if you um, have your base station and you've got a reading that's not an absolute, you're now simulating one, and you're going to put it into your base station. So you might want to go and relabel the channel that's your original gravity measure there, or even delete it. And now we're going to put this absolute on top. So I'm quite interested to see if that's what they did here. Let's see what value actually comes out. Is it going to be the same? So it is a bit different. So, I mean, this is the only way I can think to solve it. So this is just a later disclaimer. I hope it makes sense.